Guys, do you have any comments or questions?
Not at this time.
Let's see. There's some in the chat. Let's see. Is it possible to do the project using packet trace? Do we have to use the physical equipment or can we use Cisco packet trace? How, okay, what are the capabilities? It's not just this though, right? Yeah. That's certainly a question. In the past, we've always done this with the hardware. I understand the situation, right? And so so there's a few tools out there, but you have to show me that you can do everything on it, because it's not just configuring independently one firewall, for instance. Yeah. I understand that. I had thought about that myself. So you guys want to do this with a virtualized instead of the equipment? Yeah. We have to be in the classroom though, guys. I have no control over that. You realize that, correct? Okay. All right, but you just don't, let me stop the thing. Recording again. So I will speak as if the equipment is what you're using, even though I just said you don't have to use the equipment. Find some virtualization or even VMs. I'll point, I know I have a video here. That allows you to also build a network video on how to create, set up a VM as a router. So you can take a look at this and you'll have to improvise, I guess. All right, but let's talk about the project still. So we're still gonna meet in the classroom. I'm going to do lectures, basically seed lab lectures on Tuesdays and Thursdays. But you also need to show me status of the term project as you will be working on it. And maybe some of you, once you're in the classroom, will feel more comfortable and will want to use the equipment. Okay?
So for the term project, if we're using physical material, yeah, how are we going to pick up where we left off if it's not going to be finished in one day? Like if we have...
It's not, you have to build it. The way that we've done it, we used to do it in the past is, before pre-pandemic era, you would just take the equipment that was yours, kind of label it, and then you would come in, build it up, build a network, you have the commands and then run the different scenarios and document in your report.
Okay, so like if we were to not be able to finish it in one day and have to pick up like the next week, it would all be under our name with all the configurations already set up?
Yes, okay. That's right. So we have, in the past at least, we used to have enough equipment for all this for groups of 3. So every group of 3 would get a set of equipment. And that's yours. No one else can touch that. It can be used in other classes. So that whole cabinet in there that's towards the wall, that was just for this. So it's just been sitting there for 2 years. Do you understand?
Yes, that makes sense.
So I just wanted to clarify, the equipment that we're possibly using is different from what we used in 270.
No, I think it's the same.
Okay, because I know in 270, a lot of the either switches or routers, I don't remember which, didn't have a way to save the configuration. So each time you like restarted it, you basically had to restart the commands from scratch.
Okay. Well, I think this, I guess, to talk about which one is, I mean, I don't think it's a different cabinet, so it's different routers, I guess. I mean, some of them may have that issue. I mean, it's been a while, right? But, you know, like I said, it's, there's some devices in there, they're just like Cisco firewalls, and you just have to, you know, configure things. Do you see what I'm saying?
Yeah, I understand.
Yeah. Remember, these are not labs. This is your term project, okay? It's just a somewhat involved term project, a little bit long. So, but at the end of the day, you'll just have to, you know, initially it would have been that whole network. And then you do everything with relation to that, with the IP ranges and everything. Here we'll have to improvise a little. But I'm still gonna go through this to kind of lay out the project for you guys, and then you can, you know, we'll see how we're gonna implement it. Yes. All right, so this is the, as I said, basically you would implement this network as exactly as is. There's a firewall. This is the internal network where your office is, your employees. This is the DMC, so we have web servers. This is the internet. Usually attacks would come in this direction, right? Things that you would want to have, you want to have several services in here. For instance, remote workers coming in through the through the firewall and into the inside network. So one question I would ask you in the past is, you know, try to access this server. Well, obviously you can't. Then use VPN services, and now you can. Do you guys see that? That's kind of the idea here. Okay, and then you would do the configuration for them. So that's how it has been done for 10 years, right? Got it? All right, so this is kind of the central network that we would build, right? And so now let's go ahead and take a look at the other documents that could be helpful here. So you have this PDF. This is not a tutorial by any means, but it is it gives you the logic of how to build it. All right, so it's provided here. You only need to adapt some of the commands to the specifics of the device that you're using, but in general, this is the logic that you should follow. Okay, and implement all these things here. It's got some test cases also, right? As you can see here, some of the test cases that you would do for the project, some of the rules that you would implement, etc. Right, so this is definitely a document to start with and follow along as you're building the network. But it's a guide. You have freedom to kind of build it on your own, but that should give you a good idea. Okay, and then there's some slides here that just provide you some information about commands that you can use. And let me just download that instead. Okay, so let me share. All right, so as you can see, this is the document. Also provides some information, should provide some rules and ideas about how to implement things for the environment. Okay, this is mainly, this module would have been about how to set it up and the configuration of it. The second one is actually then for your project, the things that you would accomplish, okay? So, you know, ASA practical questions. So you can see here, the goal is, and then there's more commands, but basically the essence of it, more additional documents for help, but the essence of it is these questions. Okay. So now that you've built it, you would go through, you know, for the project, you would just make sure that you've implemented all of this in some way, and then you show evidence. And some of it relates to the labs as well. Okay. So, but basically you would implement it in the network. This includes pretty much everything. So this document is really like your checklist for the term project. So you just go through this and you kind of make sure everything has been implemented. Do you guys see that? Does this make sense? This is the what's required of the project. Questions? Okay, great. So exactly. So as you can see, the first module just kind of lays out, okay, design it, build it. You know, if you were building the hardware, that's how you would have done it. And then this one is, okay, now that you built it, you can ping through, start with this document, and just make sure that, you know, you take, you know, I used to tell students, just take a pen and just like mark them. I've done 1, 2, 3, 4, you know, I know how they work, document it, and then that's it. You know, as you can see, it includes a lot of the things and services. And this module has, you know, additional information, miscellaneous, that might be helpful. Okay, and then the last module, because was a little bit involved, was the radius and Active Directory. So there, again, you don't have to use these servers, but basically the idea is to implement VPN, and that's it. So you have a VPN environment, and these are just examples, not to configure with these devices, but just kind of documents that I had in the past that show you the step-by-step of configuring things. And so that's basically it, right? So you would build a network, have that list of questions, address them, document it, and then at the end of the semester, we can do like a little demo someday where you can just show what you did, and that's basically it. The Raspberry Pi was also something I really enjoyed doing, actually. Kind of missed this one. So basically the idea was just to, we built this Raspberry Pi with 2 network interfaces, and then you would use it as a firewall too. And so you can configure IP tables. So using the VM, we will cover this, but just be aware you could physically put the router, create the 2 networks, and all that information is also here. So I think you just have to read through these documents, and it provides all the details on how to build the router the Raspberry as a router, and then configuration of it. So all the documentation is there. So these 4 were really the term project. Okay, now what I'm gathering from you guys is that if you don't want to use the hardware, you're going to have to implement all of this in a combination of software like either Packet Tracer, GNS3, VIRL, and also the VM, and just kind of segment it out, I guess. This segment with 2 VMs, that segment maybe with a Packet Tracer, firewall, etc., and just show at the end of the day the commands and some of it. So usually the questions are always like this. Okay, show that it works, right? Or show that, you know, access is granted. Now put in a rule, an access control rule based on the question, and now show evidence that it doesn't happen because of the rule. And that's it. So that if you can accomplish that via other means, you know, I'm perfectly fine with it. Just make sure you submit a lab report at the end that addresses the questions. And I may change the questions a little bit or add a few more. So that's, but in general, that has always been the set of questions. So is the term project clear, guys? Does this address your concerns?
Yeah, makes sense to me.
Makes sense to you. Okay, makes sense to everyone, right? Okay, great. So as I said, let's agree on that. I'm not going to make the equipment required, but if you want to use it, use it. I have to be in the classroom I have no choice, so all the time. So use it if you want. Otherwise, start looking at any software that you think you can use for this, including the virtual machines. And of course, definitely, please, everyone, start looking at these. I didn't want to set this as one single module because there's so many documents in there. So, and again, they're not tutorials. I say this to everyone, but they're useful guides to kind of guide you in what you need to do. Okay. All right. So I think the project then has been addressed, and you can start working on it. I would say start thinking about it, and then on Thursday you can start, I guess, giving me ideas as to how you're gonna do it. All right. So read through the materials. Start thinking how you're going to do it. We will only have one term project, which is this semester. I'm assigning it early on, and you have until the end of the semester to finish it. Otherwise, we will just continue going through the different labs and examples. Okay. All right. So I'm not hearing any other questions. So let's continue today. Then, so the last topic we looked at was spoofing. And I'm recording. I'm recording today, and I'll keep recording the Zoom sessions and posting the videos. So, all right. Excuse me. So spoofing, this is what we covered on Tuesday. Okay. So we've done this. Okay. And today I was going to add the spoofing with CC++, if I remember correctly. So this is, I already covered this example, but just you have to complete that. So let me just add the assignment. So let's do spoofing C++. Okay, so today is the 27th, so let's do on the 3rd. By 10 p.m., complete C++ spoofing lab as discussed in class. All right, so complete the C++ spoofing lab as discussed in class. Okay, so today that's settled now, and we have then. So we are done with this module, spoofing. We've also addressed the term project. So you have, remember, these 4 modules are now for you to look at and kind of start laying out your term project. And now we're going to move on into TCP/IP attacks. So some additional things that we can do, and then the set of labs that we have for this. So today I'm going to do a few more examples with scapy. So let's go ahead and do that. Let me start the virtual machine. All right, so let me share. Right, so you should be seeing the virtual machine. All right, so now we're looking at the virtual machine. So let's create, let's open up a terminal. All right, so we have our terminal there. So what are a few things? Let's now move on and see how we can use scapy for certain aspects common to security testing. All right, so, you know, obviously we can do port scans. So let's say we're going to try to send, you know, as we're going to do attacks on SYN flooding, et cetera, we're going to have to know a few more fields in the packets themselves, right? So we're going to need to send SYN packets, et cetera, ACK packets. So we send a SYN packet and see whether the server will return with a SYN ACK, for instance, for various ports, all right? So let's think of a scenario where we're going to do telnet on TCP port 23. All right, so to do something like this, let's go ahead and navigate to the desktop. Okay, so let's do Python. Oops. Python 3. All right, so now we're going to run from Scapy import all. Okay, so we have that in there. Now we're going to try to do as I said, a port scan. So we can do P equal SR1 to send and receive information. And we're going to specify an IP header. Let's say for a specific IP address here. So DST equal, and then, we'll specify some IP address. So 127.0.0.1. This is going to be a TCP packet. So TCP. And here we're going to specify source port equal, this is some number. Okay. Destination port 23. But now we're going to add flags. Okay, so we have this idea of flags, and here we can specify we have a SYN flag. Okay, so, sorry, SYN flag. Oh, yeah, forgot that. Sudo right? And now we're going to, right? So you can see it begin, you know, it sends out the packet. Okay. So let's see. Let's try. I'm going to switch over to just writing a script because this is getting. I also don't know why this got so big here. All right. So from scapy .all import all. Okay, and then SR1 IP destination. Let's try 8.8.8. TCP. And it's going to be S port 636, the source port, you know, doesn't really matter, but the destination port here could be something like port 23, although that's probably not going to work for Google servers. And then flags is yes. Like that. Close it. All right, so if we try this, sudo python 3. How do I make this smaller? Why is this window so big? Yeah, do you guys know, like, why is this so? I'm having. I don't get why this has gotten.
I think if you have the 3 lines.
The 3 lines?
Yeah, and then zoom out.
Okay, thank you. Thank you. All right, thank you very much. All right, yes. So now I can see it better. All right, so SR1 IP, we're trying to basically send this packet. We're trying to do port scanning, and we're just going to look at the various ways that we can do this. This will help us, as I said, so that we can construct more attacking packets later on. So I was missing a parenthesis. I think somebody said. So now we can try it. Right. And like that. So you can see now it's sending out the packets. So the thing is, the goal is to obtain some result. Okay, so for instance, if we did, let's try to go to port 22 instead of port 23. Okay. So here we can say port 22. Okay. So we should send Also, let me actually try the previous one on my local machine. So I'll get the IP for that. I have config, so it should be 170, no, should be 10901. Or actually this one, right? ENP SO3, so it's 10.00.64. 10.00.64. Okay, and then let's just do p.show. Okay, so now we're going to try and so let's take a look at Wireshark here. Okay, so source and destination, there's the packet, goes out. TCP to port 23, and it's a SYN packet, basically. Okay. So let's try now another one. Let's try port 22, also SYN packet. But this time just port 22. Okay, control XY. Okay. And let's take a look in Wireshark. And there it is. So it's port 22 and it's a SYN packet now. Okay, so we can send those out. Now let's see if we can't send a packet to a range of destination ports, such as from 20 to 22. So let's see in, let's go back to the script. So for that, it should be, so here we're gonna have to, now notice we're gonna have to send more than one. So we use SR, the other variant of it. And we're gonna send this to a range of ports from 20 to 22. Okay, just like that. So let's try it. Okay, finish sending 3 packets. Okay, we're gonna look at Wireshark here. These should be the packets, 10, and we just have to check the port numbers. Do you guys see? So I see the 20, 21, and then there's the 22. Okay, does this make sense, guys? So these are, again, just ways of crafting packets individually. Now, if we wanted to specify a destination network instead of a single host, let's see if we can't. So let's say, yeah, let's say like 10.0, 0.9, 10, and and several others. So how can we do that? So let's go back. So I'm going to do here in IP, we're going to use SR. And now IP destination, as you probably might imagine, we can just specify a range. So let's say, let's try 24. And just on one port. Okay. And let's start at 8 here. Okay, so let's try this one. Let's go to Wireshark. So you can see it's actually trying out 2, 3, 4, 5, 6, 7, 8, 9, the individual IPs, all of them on port 22. So it's doing a destination network instead of a single host. Okay. Any questions? All right, so now let's consider, so we've already tried sending ping packets. We've already looked at TCP, UDP. So I think that's pretty much all of the different things. I'll stop that. We can do with scapy. I'm just trying to make sure I do a full review of this. Now, let's say that we wanted to do an ICMP packet with a payload that's bigger than, say, a large number, right? So we want to put in a large payload in there. So let's go ahead here. And I'm going to comment this one out. Okay, so let's do send. IP ICMP ICMP, and then the payload here. The trick is here, this payload, we can specify it as anything. So we'll just say X, some value, and then times 6,000. Okay, and this will allow us then, we can specify all the other parameters in here, but this will allow us to set a very large payload, all right, on an ICMP packet. Now, yeah, so that should be it. All right, so I think that's pretty much it as far as scapy and the review of it. All right, so we should now be ready to just get back into or get started with the TCP IP attacks. right? And that way we'll look at specific ones. But this is hopefully, you know, some final notes on how to use scapy and you know, get a little bit more functionality out. All right, so I'm going to hit Control X here. So now let's switch over then to Brightspace, and let's look at the next lab assignment. Okay, so as I said, we've completed spoofing at this time. I'm not hearing any questions about it or the homework tonight. We've talked about the term project, and now we are ready to take a look at Tcp/IP attacks. Okay. So there's several files in here, but let's just start with the PDF. Okay, so I'm going to take a look at the PDF. Okay, so Tcp/IP attack. So, you know, basically, we started the semester just looking at network packets and how to manipulate them with code with the scapy library. Then we looked at the underlying idea that we're going to sniff some packets. And then when we want to do an attack, we're going to spoof the packets and change the fields, right? So just now, I just had my last set of notes on scapy. I don't have anything else anymore. So from what you know now about scapy and how to craft packets or how to sniff packets, you should be able now to write the necessary attacks for this lab. Okay, so here we have several scenarios. So let's get started. So the overview. The learning objective, let me make sure. So the learning objective of this lab is for students to gain firsthand experience on vulnerabilities, as well as on attacks against these vulnerabilities. Now, this is vulnerability specific to networking. Remember what I said here. This is not like exploiting a software vulnerability that somebody wrote some code in Apache and the code was badly done and they left a buffer overflow and now you can exploit it. That's not this type of attack. This type of attack or this family of attacks relates to the protocols are what they are. They're not, there is no software misconfiguration or misimplementation. The software is written correctly, but the protocols are what they are. And therefore, what you're going to do is you're going to try to exploit those protocols. So that's really what this family of attacks is. So the learning objective is for students to gain firsthand experience on vulnerabilities as well as on attacks against these vulnerabilities. So, you know, wise people learn from mistakes. So we study mistakes that lead to vulnerabilities. Studying mistakes from the past not only helps students understand why systems are vulnerable and why a seemingly benign mistake can turn into a disaster. And therefore why security mechanisms are needed. More importantly here, it also helps students to learn common patterns of vulnerabilities so they can avoid making similar mistakes in the future. But moreover, using vulnerabilities as case studies, students can learn principles of secure design, programming, and testing. So anyway, the vulnerabilities in Tcp/IP protocols represent a special genre of vulnerabilities in protocol design and implementation, which is what I was saying. This is a different kind of problem. They provide an invaluable lesson as to why security should be designed in from the beginning, rather than being added as an afterthought. Moreover, studying these vulnerabilities helps students understand the challenges of network security and why network security measures are needed. So you guys saw, for instance, that we were able to ping, if we had a ping and we were sending it out into the network, we were able to get a reply back. And we were able to spoof that. We were able to fake it in some way. So in this lab, students will conduct several attacks on TCP. So the lab covers the TCP protocol, TCP SYN flood attacks and the SYN cookie mechanism, TCP reset, TCP session hijacking, which is an interesting one, TCP reverse shell, which you guys have already done reverse shell in the buffer overflow labs in 450. Now we're going to see how to do reverse shell, in the network. Remember, not by exploiting, not by writing into memory like in a buffer, but just in a slightly different way. A special type of TCP attacks, the Mitnick attack, is covered in another separate lab. Right, so this corresponds to chapters 16 of the book. So you can certainly take a look at that. And all this has been tested on the 2004 VM. As far as the lab environment, basically we'll be needing at least a couple of machines. So you might want to have a second computer. And then this is the information on the containers, as you know, Docker and everything. All right, so let's take a look at some of these attacks. So the SYN flooding attack is a form of denial of service attack in which attackers send many SYN requests to a victim's TCP port, okay? But the attackers have no intention to finish the three-way handshake. Attackers either use spoofed IP address or do not continue the procedure. Through this attack, attackers can flood the victim's queue that is used for half-open connections, i.e. the connection that has finished SYN and SYN-ACK, but has not yet gotten a final ACK back. So when this queue is full, the victim cannot take any more connections, and so that's where you have a denial of service attack. The size of the queue has a system-wide setting, and in Ubuntu OSs, we can check the setting using the following command. So you can see that there. All right, so you'll run that command. You can also use netstat-nat to check the usage of the queue, the number of half-open connections associated with a listening port. The state of such connections is SYN received. Okay, netstat space -na, pipe grep TCP will show you that. Now, if the three-way handshake is finished, then the connection will show as established. There is a countermeasure called the SYN cookie mechanism. By default, Ubuntu SYN flooding countermeasure is turned on. This mechanism is called SYN cookies. It will kick in if the machine detects that it is under a SYN flooding attack. And we can use the sysctl command to turn it on or off. Okay, so you can see these are the commands to basically take a look at it and turn it on or off. SYN cookies is basically a way of hashing the information back out so that you don't have to keep the information in the queue. So these commands should work on the VM, okay? So I suggest, some of you can try the container with the VM. It's always been pretty straightforward to run these commands. So we'll see that with the Docker. Okay. All right, so to launch the attack, so there's a couple of ways that we can do the attack. Obviously, there's a tool called netwalks that we can use. There's a C program called synflood.c that you can use, or you can just do the SYN flooding attack with scapy. Okay, so either way, you just need to, now I just showed you how to construct SYN packets, so you can just test it out that way. Okay. Now, you'll need to have two VMs. One VM will need to have an open port, port 23, and then usually you target that port and you just send a flood of attacks. So you can see here, for instance, assuming this is your script, this is the target, and then here, this is the open port. Now, when you run this attack, you can run netstat-na, and your output should be a lot of half-open connections. Okay, so we'll work on that in a second, so don't worry about it. I'm just laying this out right now. All right, and then there's the SYN cookie countermeasures. Here's the, so let's see, we can use scapy here. So usually when you do this in it's difficult to get the machine to crash with this attack usually because the computers have a lot of memory. But when we used to do, this is actually one of the reasons why it was nice to do this in the network equipment, because we could run this attack on the routers, for instance, and we would see that the router would notice that it was being SYN flooded and attacked. VMs have a lot of resources. It's difficult to like break them or have them stop, but at least we should be able to see the half open connections when we run the attack. Okay, so we'll take a look at that in a sec. So yeah, so let's just focus on that one for now. All right, let's start thinking about how to build a SYN flooding attack with scapy. So you can see we need a TCP header, and the IP destination. So, all right, so let's go back to the virtual machine. And the simple scenario for a denial of service attack is like this. You do netstat-na pipe grep TCP. Right, when you see this, there's no information here. There's no halfway connections. Once you run the attack, you're gonna see you should see a whole bunch of connections here, but the connections should say SYN-ACK not established, which basically means that they are, it's a whole bunch of connections that were never really closed, right? So let's try that. Try to build that script. Okay, so to do this, let me just open up my notes here. All right, so now to do this much better, you might want to have two machines. Remember, you ping first between the two machines to establish that you can reach them. Okay, then after that, you would set up sudo sysctl -w net dot IPv4 net.ipv4.tcp SYN cookies equals 0. Okay, so set the parameter. Right, then we can check netstat. Let's say on your other machine, -NA pipe grep TCP. All right, port 23 and port 22 are open, so I can target those if I want. Okay, I'm just going to do this on my own machine. You should first check netstat, as I said, netstat. Okay, like that, listen, time, wait. All right, so you know nothing has happened. Okay, so now let's try, let me try, all right. Let's try it now. Okay, so we've got NetWalks there. NetWalks is a tool for attacks. NetWalks is a simple tool for attacks. So one way of trying this out, then it's going to be sudo netwalks 76. Okay, that's so when I type a number on this tool, that just basically means is the type of attack that I'm doing. All right, so 76 would be a denial of service attack. Now I'm going to target my local host, let's just say 127.0.0.1, and I'm gonna attack on port 23. And let's just say -as raw. Okay, so it's thinking there. I'm gonna open up another window, and I'm gonna run netstat -NA pipe grep TCP. Okay. And this still looks pretty big. So what do you guys notice? What would be your observation if you look at this one? Guys, can you hear me?
Yes.
So what would be your observation? Was the attack successful or not?
Yes.
Why?
There's a lot of SYN packets coming in on port 23.
Right, there's a lot of SYN receive packets, right? All these here. And what this means is if you had an actual connection, it should say established, right? So what that means is that, SYN, SYNX, so SYN receive was there, the connect. So these are half open connections, okay? So we were successful in launching the denial of service attack. And because we're using netwalks is kind of written in C, so it's pretty efficient. So you don't really have to, I mean, as long as you use this, that would be great. The other suggestion I would make is implement this in scapy itself. But as far as slowing down the computer, killing it, anything like that, I'm not looking for that. It's enough if you show this, plus also you should show, of course, your Wireshark output, right? And that's also recorded there, which you should be seeing here. That's it. I mean, it's not really meant to be anything more than that. All right, let me go back over here. I'm gonna close it now. All right, so I kill the command, and these are still gonna remain for a while because, you know, it takes a while for them to clear. But basically, that's the activity that was happening in the environment. Notice that the IPs are spoofed, etc. And so this is the denial of service attack. So as you can see, it's pretty straightforward. Are there any questions about this one? Anything you didn't understand? All right, great. So that's pretty much the first problem. All right, so homework, somebody's asking me about the homework due tonight. Remember, the homework will stay open until Saturday. So tonight is just your soft deadline, and then your hard deadline is Saturday. So it'll stay open. Got it? Okay, great. All right, so that was the netwalks example. Let's take a look. All right, so that's that attack. So let's go back to the PDF to make sure we've covered everything. Okay, so we still need to write the script. Yeah, and then the next set of problems. So today I'm not assigning this homework yet. So today I just, you know, kind of wanted to demo one of these, the SYN flooding. Next week, we're going to focus on other attacks like this TCP reset attack or the TCP session hijacking, which is actually one of the longer and more complicated ones. But at least now we've had a taste for SYN flooding. Okay, so that's basically all that I'm going to demo tonight of this, and the rest of the time I'll just stay here if you have any questions about any of the homework assignments that are due tonight. Okay, so I'm going to go ahead now and stop the recording.